This week on Quality Digest Live, we chat with Ed Morse of UNC Charlotte about metrology, industry, and academia.
Plus, embracing uncertainty. That and more when we come back.
And welcome back to Quality Digest Live for April 8th, 2016. QDL is your weekly look at who and what is making the news in the world of quality. I'm Dirk Ducharme, Editor-in-Chief of Quality Digest.
And I'm Quality Digest publisher Mike Richmond. Well, April 8th, Dirk, you know what that means. Smack dab in the middle of allergy season.
It means 1 week before taxes.
That too. So if I start sneezing a lot, you'll know why. I'm not just sneezing because I'm allergic to you.
Yeah, all right.
There must be some ragweed or something, but anyway. Well, just a little FYI.
Ammons.
Right. Ammons. All right, well, we're going to start the show this week with a great little piece that recently appeared on the MIT News blog. We republished the article titled Plotting the Complex Path of Products in yesterday's issue of Quality Digest Daily.
Interesting story.
It's great, really interesting story. Now, it's no secret or surprise to note that today's global supply chains are massive and they're complex as well. But the true nature, the actual routes of products and parts as they move through that system has always been something of a mystery, at least to ordinary companies working within it, not to mention consumers purchasing the stuff that comes out of it. But a software platform called SourceMap may be changing this equation a little bit. Developed by a then MIT PhD candidate by the name of Leonardo Bonanni, SourceMap not only shows every supply chain connection on a digital map, it also takes into account macro events such as the weather or a region's political climate or act of God type disasters. The object of SourceMap is really twofold. First, it helps provide customers with insight into the provenance of the products that they buy. Second, it helps those companies working with suppliers to better understand their own supply chains and to take steps to address potential vulnerabilities. Now, we all talk a lot about risk management, right? I mean, we just had a webinar on the topic just this past Tuesday that many of you attended. Now, this right here is a really practical tool that very much helps companies visualize and mitigate risk. The example that's used and is referenced in the article as well is the Japanese earthquake and tsunami back in March of 2011. I can't believe it's 5 years ago.
I know,
already.
it doesn't seem like
that. It's amazing. Fukushima's 5 years ago already. This disaster, of course, as many of us will recall, knocked out many key suppliers within industries such as automotive, electronics, chemicals, retails, a lot more, for weeks if not months. So better understanding of the supply chain could have, perhaps, and probably would have, helped many of those OEMs avoid or at least minimize these disruptions by having alternatives in place, or at least by being able to quickly identify those alternative suppliers after the fact. So SourceMap really, if you think about it, is a risk management tool. I mean,
Sure.
You're able to, if you don't already. Now, when I said that smaller companies really can use this, because large companies kind of have this in some way in a proprietary way. They can afford to throw a lot of resources at this, and they kind of know a little bit better. But smaller OEMs maybe don't have access to that. But even, consumers certainly don't.
But
either.
even bigger ones. I mean,
Yeah.
the idea of being able to visually see the path
actual path. Yeah.
That's because if you don't see the path, you may not necessarily understand that path is going through maybe a country that's currently under turmoil, or a country that's going some sort of natural disaster, or maybe even economic disaster. Yeah. And being able to see those paths actually make a lot of sense. And as you said, the overlays are interesting.
The number of paths. I mean, the number of places that these go. I mean, the author of this piece talks about the fact that it almost touches everybody in the world when you think about the number of countries it goes through, right? And the number of hands that touch a product as it gets to you, whether it's a computer chip or food or whatever it may be. I mean, it's really touched by a lot of hands before it gets to you. And yet, like you say, the overlays are cool because it's looking at things like weather, political climate, act of God, disasters. I mean, these things that are outside of just simply the pathways of where the product's going, but can help consumers or companies understand the risks inherent in the supply chain if it's disrupted by a natural disaster or by weather or by political upheaval. I mean, any of those things can disrupt the supply chain, and if you don't have alternatives in place going in, you're likely to maybe have some disruption. You're going to have some disruption at some point. So this helps to alleviate that a little bit. Really cool little tool there called SourceMap. So check out the story. Again, all the articles Dirk and I are covering, as always, in the show, right below the player page down there. So check that out and look at SourceMap. Cool thing.
There we go.
Yep.
Oh,
All right.
we have a guest coming up.
We do. We do have a good guest. And as we all know, new workers in manufacturing, they don't just spring fully formed into their jobs. They need to learn the proper procedures and techniques to, for example, measure something correctly, or do some sort of a function within the shop floor of metrology. Some of that knowledge now is passed along, as we know, from worker to worker within the enterprise. But academia has an increasingly important role in preparing the coming generation, specifically of test and measurement professionals, for success also. That's why this episode of our monthly CMSC Corner segment is, I think, especially important. The Coordinate Metrology Society, of course, is the world's leading membership organization for those practicing the art of portable 3D metrology. Their annual event, the Coordinate Metrology Society Conference, for which Quality Digest, of course, we're a proud sponsor, occurs each and every summer. CMSC 2016 is going to be held in the suburbs of Nashville, Tennessee in late July this year. Now, if you come to CMSC 2016, you're going to hear some great case studies, see an amazing array of hardware, software, and peripherals, and meet many of the leaders in this field, including today's guest, who happens to be a leader in academia as well. See how that all kind of comes together nicely from the beginning? That's right.
Almost like you planned that.
Almost. Edward P. Morse is a professor of mechanical engineering and engineering science at the University of North Carolina, Charlotte. He's also the deputy director of the university's Center for Precision Metrology, and he serves as the chair of the Precision Path Consortium, which has been formed between the Coordinate Metrology Society and UNC Charlotte. So, Ed Morse, welcome to the show.
Thanks very much. It's good to be here.
Thank you for being here with us, Ed. Well, let's start with a quick update. So, what's the latest going on with the Precision Path Consortium?
Well, at the end of February, we had a meeting here in Charlotte at our Center City campus. We had 20 professionals from throughout the key industries in large-scale manufacturing, especially those people that use portable metrology. And we did a lot of hard work studying different application scenarios for portable measuring equipment and the various technological attributes that these instruments must have in order to perform those tasks. So we had this meeting and we asked a lot of questions and we honed those questions, we fine-tuned them, because our next step is going to be producing a survey that's going to go out to hundreds of people, thousands of people, probably many of them in your audience, and looking for their input and expertise on these very issues.
And Ed, what is your role as co-chair?
Well, I kind of try to keep things moving behind the scenes. So one of the important things is to administer some of the details of the federal funding, because although we have a lot of support from industry, we also have federal support, and it's our duty to be good stewards of the taxpayers' money. Ron Hicks is co-chair with me, and together Ron is really doing a lot of the communications. He's great at that, and he knows so many people in the field. And I'm working with our team here at UNC Charlotte, which is doing some of the preparatory work for the survey and also laying the basis for our industrial roadmap that we're putting together.
And Ed, talk a little bit more about that survey. You said that you've kind of been accumulating this information and it's going to be released very soon. So what exactly, I mean, if you can give us a little preview of that, what exactly can we expect to see from the information that you're gathering?
Well, I think that we'll get an informed view of how the industry is evolving. So one of the strengths of our consortium is that we're looking across a number of industries. So I think within aerospace, the needs may be fairly understood, but only understood by the people that work in that industry. And the same may be due to shipbuilding or large equipment manufacturing. And I think by reaching down to the people that are doing the work day in and day out, we'll have a much more accurate feel of not only how the tools are being used, but what the needs are. So for various application scenarios, say keeping things aligned as you assemble them, what are the real needs? And then we can look at different instruments to say, how do these instruments need to improve to make this work better or faster?
Now, Ed, you're going to be keynoting CMSC 2016 this summer, only in a few short months. And of course, I know it's early, and I don't want to put you on the spot. But can you maybe give us a little sneak preview, a little first look at what you're going to be talking about in your keynote this summer at CMSC?
Well, I think that a lot of what you've talked about so far has set this up really well. I think there'll be some really interesting information coming out of our survey, and I'll be sharing that at the keynote, so the people that are attending will be the first to hear this information. I'll also talk some about the importance of education and the role different institutions are playing in education and trying to overcome the issues with the graying of our workforce and looking to fill the ranks with young metrologists and young engineers.
Well, I spoke a little bit in my intro about the ways in which academia and industry work together. And of course, we all know it's very, very important that each support each other. So what do you see as the role of academia in supporting industry, and vice versa? How can industry help support academia as well?
Well, I think that from the academic side, there are two main roles. The first is on the research side, our ability to take a longer view at problems and not be driven quite so much by what is about to happen or what could possibly happen in the next day before my boss appears on the shop floor. And we also have, with that distance, we have the ability to look across industries. So often in industry, you're driven by the clock and solving a problem that needs to be solved, which of course is what makes the money come in. But we end up reinventing the wheel in different industries because there isn't a good way to exchange information, and there isn't a way to solve the root problem. We keep addressing the problem that's facing us every day on the floor. And the obvious second part is workforce education. So future engineers and technologists need to have some exposure to the tools that they'll need, and we want to provide not just something you would call training, but we really want to educate them. We want them to understand the fundamentals of metrology and manufacturing, and that will allow them to quickly learn whatever they're faced with out on the shop floor.
And Ed, I'm glad you brought that up. I mean, we haven't heard the term skills gap quite as much as we were a year ago. It was probably in the news all the time. And it was kind of a debated topic. You know, you'd have people in industry saying, look, there's a skills gap. We can't find the technically sophisticated people that we need for today's, high technology, workplace. And then you'd have other people say, oh no, there's no skills gap, that's just a ruse. From your position in a university, teaching people skills, what is your perception of that? Do you feel that the universities are able to keep up and put out students that have the latest and greatest knowledge of technology and skills and so forth that today's workforce needs right now?
I think that we can, and I think that we do, but I think that the balance isn't always perfect. That there will be times when what we're looking for is skilled workers who would benefit most from a technological education at a community college, an apprenticeship style program. And then there are other people who would benefit more from a full undergraduate education where they have more in-depth knowledge in certain design areas. And I think sometimes the perception of what is offered at various institutions and the expectations of what is coming out sometimes don't match the experiences that the students have. And I think every time we write down everything we would like our young engineers to know by the time they finish 4 years of college, it turns out that what they really need is a master's in mechanical engineering and a PhD in physics, because everyone has their own thing that they think they should know. So
I guess that's a problem also is technology moves so fast, and like you said, you got a 4-year production period for your students. By the time 4 years have passed, boy, technology's come a long way.
Yeah. That's right, and that's why we have to focus both on the underlying principles that they have to learn, and not just give them specific skills, but really give them the tools they need for understanding what engineering is all about. And they can use that as a platform to attack the new problems that we can't anticipate.
Well, Ed Morse, thank you for joining us today. Corner segment. We appreciate it, and of course, remind everyone out there, Ed is keynoting this year's CMSC. So if you're interested in learning more about that, check out www.cmsc.org. And Ed, we are going to see you then in July in Murfreesboro, right outside of Nashville. Thanks again for joining us today, and we'll see you then.
I'm looking forward to it. Thanks very much.
Thanks, Ed. Talk to you soon.
See you, Ed.
Okay.
All right. Well, this past Tuesday,
Yep.
we had a great webinar on the tools of risk management led by Mike Micklewright. It was a great webinar. Mike described a lot of the tools that you might use in risk management, such as FMEA, risk priority numbers, and so forth. And he discussed as well, methods of mistake proofing to avoid adverse events. At about the same time, we ran an article by Gilles Hillary titled "Embrace the Fuzzy Crystal Ball." In that article, Hillary essentially makes 2 points. First, humans don't like imprecision. We prefer knowing that the odds of winning a single number on roulette are, say, 37 to 1, for instance, and not just slim. We prefer that, you could say your odds of winning at roulette are really not very good.
Yeah.
But we prefer to know what it actually is.
Actually,
37 to 1.
Right.
And in fact, says Hillary, we are willing to take long shots like roulette, even if we know the deck is stacked against us like roulette, as long as we know exactly what that risk is. And think about how you respond to numbers and statistics, et cetera. I mean, it's an election year.
Yeah.
I mean, we get polling numbers all the time. We get percentages all the time. We like to know what those numbers exactly are. It doesn't matter just to say, Bernie Sanders is leading Hillary Clinton in Illinois, by a little bit.
Yeah.
No, we want to know what the spread is.
52% is different than 51%. Sure,
exactly.
Sure. I get yeah.
Well, that's one point. Hillary's second, and I think second point, and particularly in the business world, is that we feel safe. Like we have the whole situation sussed as long as our tables and pie charts and control charts and FMEAs and RPNs give us some real quotes data, even when the data really isn't so real and it's kind of iffy at best. And Hillary puts it this way. I love this quote. Hillary writes, "Models, particularly those with a veneer of complexity and sophistication, cater to this aversion. Various academic studies suggest that seemingly more precise numbers can act as more potent anchors, and that when presented with more information, people tend to be even more overconfident of their capability, even though their actual performance does not improve." So data do not guarantee knowledge. And this has some big implication for risk management. I mean, just because you thought of every possible risk and then prioritized those risks and then created preventative plans and remediation plans doesn't mean that you are all set. I mean, as they say, haven't heard this one for a while, but you don't know what you don't know.
Right.
So that means you have to prepare for uncertainty. You have to prepare for what you don't know. How can you do that? I mean, how can you prepare for something that you don't even know is going to happen? I mean, it kind of sounds like a silly notion. Most people would argue, well, look, all we can do is think of every possibility and try to plan for that possibility. And those things that come up, the black swans, well, they just happen. Yeah. Well, to a certain extent. But I actually do believe that you can plan for uncertainty. I think that you can have a plan for what to do when you don't have a plan. And we actually talked about this a long time ago, and I can't remember what they were called. I recall them as being something like emergency action teams. Mm-hmm. So maybe what you do is you create cross-functional emergency teams for different types of unthought of events. So what do I mean? So you might say, well, okay, we don't know every possible supply chain event that might happen. But if some black swan supply chain event happens, we still have to respond to it. So we have an emergency response team for a supply chain incident. And we have what we believe are the right people involved in that team. And we might have a team for an adverse financial event or for an adverse product liability event that we never even thought of. We might have one for a local catastrophic event and so forth. So you got to think about what expertise would each type of event need and who your company should be on that team. And then you build your essentially contingency teams. And maybe you even have an emergency response manual. Who does what when? What's our first steps? Where do we meet? Where do we meet? Right. And then of course you got to consider resources they're going to need. So in other words, you might not know, which you don't know when it comes to risk, but you do know who you would want to call and have on your team in case some event happens. So you can actually plan for black swan events without even really knowing what that event might look like. And so in that sense, you can prepare for that unplanned event, something that you never could have imagined would have happened.
That's an interesting perspective because, I mean, you don't know exactly what it's going to be, but you know if it's in a certain area, you know who the people probably are on your team that are going to be best equipped to handle that, whether, again, it's financial or supply chain or whatever it may be. So, kind of pre-positioning that emergency response team is a really valuable thing to do. If you think about it, I mean, it's really helpful to be able to do that. And ultimately, I mean, that's what you want, is you want those people to be able to be there and be ready to act in case that black swan comes.
And like I said, you could even have initial responses. Just the first few things that team gets when they're called.
Right.
What do we do? Who do we call? Where do we meet?
Right.
And you can plan for it.
You can plan for it.
It can be a process. Yep.
That's great. That's great. Well, thanks, Dirk. Okay. Well, it's time now for our Tech Corner, and this is where Dirk is to show us some great new piece of technology that's going to make our life easier, or maybe as normally he's just a geek who likes to play with tech toys. Well, in any event, today's gadget is from the Paul N. Gardner company, Gardco, and this is a USB digital microscope. We've seen one of these before, I think, haven't we, Dirk?
Yeah, Mike, we have. I mean, I think a few years ago we had a USB digital microscope. There's quite a few of them out there. They kind of comes in different shapes and sizes. This one happens to be from Gardco, and I'll just show you real quick what it looks like. We'll hold it up here to our gauge cam. There we go. You can see this is kind of the business part of it. It's just a little, 4-inch long tube, maybe 1.25 inches in diameter, little focus knob right here, integrated LED lighting. I mean, when you get down to it, this is really just a web camera with microscope optics in front of it, and it plugs into the USB port on your computer. Now, the way these typically work, the way this one works, and come back to our main camera here. The way this one typically works is that given any working distance from the objective to your object, it has a low magnification and a high magnification. So this is kind of, a lot of people aren't aware of this with these, there isn't a continuous magnification from, let's say, 20x to 200x. It basically, you set the working distance by how close you put this to the object you're going to measure, and then you have a low mag and a high mag that you can switch between on them. And let's take a look at that. If we come over here to our gauge cam, our software. Sorry about that. So this is the software that comes with the Gardco device, and I happen to be on a low magnification on a key right now, and I've adjusted the ring light, so I've got really nice lighting. And if you look at this, this is probably, maybe 30, 40, 50x, something like that. And you can see the quality of the video, the quality of the image is very nice. By the way, I can take either a snapshot or a video of what I'm looking at here. And as I'm going around the edge of the key, you can see this works really well for visual inspection. Now, if I wanted to annotate this using this software, I could simply snag a picture of it, and I'll do that. I take a picture. I can now open up that picture, and let me expand that picture out a little bit. Let's do this, kind of do that. Let's zoom in a little. Go zoom in, and I want to annotate this a little bit. So I'm also going to set up. I'm going to set up the size of my font so I can leave some legible notes. Let's do white text, something like that. Okay. I also have to set the magnification. So I look on the barrel what magnification I'm using. It tells me on the barrel of my device that I'm at about looks like 34x. So I type 34x up here, and I'm actually now ready to take some measurements. So I can take my measurement tool, I can run down there like that, and I can measure the width of that. I'm not sure if you see it there. I did it in white text. Let me change my text color just to make it a little easier on you. Let's go something black here. Okay, so let me take that measurement again. There we go. And now we can see the width of that groove is about 1.3 millimeters. I can also measure angles. So I can come over here, click, roll over here, and of course it's down in the dark, so I need to change my text color again, but you get the idea. I can measure angles, I can measure diameters, radiuses, lengths, and annotate. I also can put a text box in here and just annotate what I've written. So now Gardco is very upfront about this. This isn't a super precise software or piece of hardware. This is an inexpensive tool, visual inspection tool. And the dimensional readings you get on it are reasonably close. If you're doing rough measurements, they'll be fine. If you're looking for something super precise, this is not the instrument for you. You want something that costs a whole lot more than what this would cost. But as a visual inspection tool and a way to just quickly go through and measure things, take angles, it works very well. So we were looking at a low magnification. I'm going to show you what high mag looks like. So I'm going to leave my camera right where it's at, and now I'm going to switch to high mag. And we'll find an appropriate spot on this key. Let's do it here. We'll bring it into focus. There we go. And let me throw a little bit more light on it. By the way, the ring light on this is adjustable. This could probably stand to have a bit more, so let's crank up the volume a bit. There we go. So now you can see I'm at probably, I don't know, 200, 300 magnification on this. You can see I can see every single scratch on that key. I can see every single nick on the teeth. So for a visual inspection tool, this actually works pretty darn well. And if you think about it, typically in a lot of places where you would do this kind of inspection, you would be using some sort of inspection microscope. And if you've ever worked at a microscope for any long period of time, you know that can get a little tiring. This you just plug into a computer, a laptop, a desktop computer. It's displayed right on the screen. It's a very easy interface, very, very ergonomically comfortable for people to use. Now, I want to tell you kind of another function here. We can come back to the main cam. Another function that we have here that is kind of undocumented. In the documentation for this Gardco USB digital microscope, it says that the working distance is 10 millimeters to 500 millimeters. And I believe that's because that's where its accuracy is if you're trying to take measurements. However, if you use it just as a camera, and it is essentially just a webcam with binocular on the front of it, if you use it just as a webcam, it actually focuses to infinity, which means you can do some other things with this that are a little undocumented. So my use for it is actually as an inspection camera for larger areas. And we'll come to one here. What I'm going to do is I'm going to aim this over at we can see over here, I have a little printed circuit board over here. Now, how you normally might use this is I would recommend mounting the camera on a boom above your workspace and putting your printed circuit board underneath it like that, so the camera is permanently mounted and you just focused and you move your circuit board around, but that's harder for me to do here, so I'm just going to do it sideways. And now if we come back to our software, I'm going to focus on that circuit board. There we go. So now I'm focused on the circuit board, and now I can do a visual inspection of solder joints, which is a very common inspection function in electronics. And I could use the camera to scroll around and look at all the solder joints close up on the back of this circuit board. And if I found one I didn't like, hey, guess what? I take a photo of it, open up that photo, I can zoom in on it a little bit. Let me select a font. Let's go to a big font here. There we go. Select a font, create a text box, and I can say, bad solder joint. If I spelled it right, can't type, don't have my glasses on, solder joint, there we go. And I could even draw an arrow. So I could take an arrow from my little note and draw it down to a suspicious solder joint right there. Save this out, and there you go. Your inspector has documented a bad solder joint on a circuit board that can then be printed out, put on a report, saved in an email, whatever. So this is actually just kind of a neat little something else that you could do with this tool besides using it as a microscope. Like I said, it will focus to infinity, so it's pretty useful. They're relatively inexpensive, as I said. So this is the Gardco USB digital microscope. There's a link underneath the player page. If you click that, that'll take you out to their site, onto that page, and you can read more about the specs on this device. So that's it. Mike, back to you.
Thank you, Dirk. And yes, there it is from Gardco, the USB microscope. Very simple device, a very practical device. A lot of uses that Dirk gave you for that one. And I think there's probably some other ones that we haven't even didn't cover there, Dirk. So
cool.
That's a cool little device for all of you out there.
And let me mention, you don't have to use their software. It does show up as a webcam on your computer. So if you didn't need to do the measurement or some of the other functions of their software, it'll just open up as a webcam. Yeah. And so you could use it on Skype if you wanted to share information over Skype or whatever. whatever. So it actually it's pretty cool.
It's got a lot of cool functionality there. All right. Well, thank you, Dirk. Thank you, Gardco, for sending that to us. Thank you, Ed Morris, for joining us earlier in the show to talk about the Precision Path Consortium. And thank you all for joining us. That is our show this week. We'll be back at you next Monday with a full week of QDD, Quality Digest Daily, and we'll be back right here on Friday with Quality Digest Live as well. So all of you have a great weekend, and we'll see you then.
So long.
Bye.